All right, so we need to first make sure you understand what a system of equations is, okay? Obviously, you know what one linear equation is because we just finished a unit on it, but a system of equations is two or more equations. Okay, we are just dealing with a system of linear equations in this chapter, but the further on that you go, I mean, you could really graph any two equations of any shape and find solutions or, you know, lack of solutions, but no. The technology piece is going to be in Algebra 2.
The way I learned last year, he had us do it on graphing calculators, so I never knew like
how to do it by hand. You are learning the 3 ways to do it by hand, and then later on, after you do all the work in Algebra 1 and learn how to do it by hand, then in Algebra 2 you'll learn how to do it with a graphing calculator. You know, it's not a bad thing because then you understand, you know, how all those pieces. Right, yeah. Okay, so a system of equations is 2 or more equations, okay? A solution to a system would be the point or ordered pair where the graphs intersect. Okay. Now when you think of linear equations, we have 2 lines, and the only way they're going to intersect is in one place, if they do, right? It's not like having a curve where you could have 2 intersections. 2 lines, if they intersect at one point. Otherwise, they don't intersect. Well, we'll talk about that too. If they're the same line, obviously they intersect everywhere. So then they'd have infinitely many solutions. Okay. The other option would be parallel, which means they don't intersect at all, ever. We're going to deal with the ones right now today that intersect in one point. Okay. So the method that we're using today is graphing. Okay, and you're going to graph each line in the same coordinate plane. And then we're going to look for an intersection. Okay, so the 2 equations that we're dealing with are these 2. So obviously you need your XY axis. Most of the ones you're going to be doing are in slope-intercept form. Okay? There are a few peppered in there that are standard form, and we'll review again how to graph those. Long way would be to rewrite the equation so it's in slope-intercept, but you know, the quicker way is using the x and y intercepts. So we're going to start with the one in red. Now remember, these are in the form y equals mx plus b. So our y-intercept would be -3. And you are going to start there. And that is on the y-axis. So we are down 1, 2, 3. And you actually do put a point, remember. And then we're going to use the slope to rise and run to get other points. So our slope is 2, but to put it in the form for rise over run, what would you do? It'd be 2 over 1. So from our y-intercept, we rise 2, run 1. Now you're going to probably want several points because I'll show you what sometimes happens. Whoops, not there. Rise 2, run 1. Or you could go down and to the left. You probably want both sides of the y-axis because we don't know yet what the other equation looks like. Okay, so there's my first line. Now the other one, same thing. We need our slope and our y-intercept. Our y-intercept would be what? -1, and our slope, 1. If there's nothing in front of x, remember it's not 0. If it were 0, x wouldn't even be there. So the slope is 1 over 1. So we're going to go down 1 and put our point. And then we rise 1, run 1. Rise 1, run 1. And actually that's kind of handy because we end up, there's where we cross the other line, right? You might want to go beyond it. And we'll go down to the left also. Okay, so we graph both lines. And the next part is to find the intersection which is right there. I didn't do my red line very well, but okay. So that's my intersection. And it's not enough to graph both of the lines, go, yep, they crossed, I'm good. We want the intersection, we want the ordered pair. So we write the ordered pair that represents that intersection. So this would be 2, 1. So the solution to this system would be 2, 1. Okay, now the one thing I suppose I should add up here is your solution, okay, so we'll add that in. The solution is the x and y values that make both equations true. So, if I wanted to make sure that 2, 1 is truly a solution, if I go up here and plug in 2 for x and simplify that, do I get 1 for y? 2 times 2 is 4, minus 3 is 1, so y would be 1, right? And then if I go over here and plug 2 in, 2 minus 1 is 1, so y would be 1, so that works, okay? So your solution should work in both equations. So if you want to check, you know, test or quiz and you have time, good idea to check. If you plug it into both, it should make both true. If it doesn't, it is not the solution. Okay? So let's look at another one. Okay, now the biggest thing for people who know what they're doing with the graphing, the biggest thing I see happening that is wrong is the actual graph of the line is wrong. Maybe someone did the intercept correct and they did the slope wrong. So your graphs need to be spot on or your solutions aren't going to be right. what is my slope for the one on the left? It's 1. There's nothing in front of the x, so my slope is 1. And my y-intercept is 5. And I always start at that intercept, right? So Michael, where is my y-intercept? Where do I go to find it?
+5.
Up, down, right, or left?
Up.
Up. Okay, so 1, 2, 3, 4, 5. I put a point because those intercepts should be right on the axis. Okay, now from there I have a slope of 1, which is rise over run. So if I don't have the run, then it's 1. Hopefully you don't have the runs. Just kidding. All right, so rise, run, down and to the left. That time of year. I think you're the only one that caught that. Okay, so there's my first line. Now, what happens with my second one? I have y equals mx. Where's the plus b? Yeah, my y-intercept is 0 because if I'm looking at mx plus b, well, there's my slope, -4, but there's no b. So the only thing b could be is 0, right? That just means you're starting at the origin. So I actually do have a point here. And here's where you want to be careful with that negative slope. You can either go down and right, yes, because we want our line to go this way for negative slope, right? This is where people go wrong, are those negative slopes. And I usually see your graphs will be a mirror image of what they should be if you've done the slope wrong. So we go 1, 2, 3, 4, and to the right. Or we could go 1, 2, 3, 4, and to the left. And the nice thing with this one is you ran right into the line. Okay. Now, before I put that point up there, here's what some people will do. They will connect their 2 dots and go, nope, those don't intersect. Okay. Do lines go on forever, or are they just a little piece?
They're just a little piece.
A line segment is a little piece. Okay? You could say the segment in the line don't intersect, but if you're graphing the whole line, they will intersect unless they're absolutely parallel, and there's a way that we're going to learn how to verify parallel lines. But if they're not parallel, they will not, or they will intersect eventually. Now, so you want to continue, you actually want to go towards your other line, okay? We're not done because we need our intersection. What's the name of that ordered pair? From the origin, I walk first, and then I fly. So it'd be -1, 4. Okay, so my solution is -1, 4. Okay. Okay, so